Okay, now that we know all sorts of things about electrons and what sort of shapes they travel in, and we will talk a little more about shapes later, we need to talk about light because light is truly astounding, and light comes from electrons. We'll learn about that later on as well. First thing I want you to know is that light is energy, and you should definitely be taking notes right now. Light is extremely strange, and it's why it has taken us so long to understand light, and we still do not totally understand light. But light is both a particle as well as a wave. So it's sort of a particle that travels in a wave. And so you can think of light as being a little bundle of energy that travels in a very distinct pattern. So energy that's light always travels in a wave pattern, and it literally is doing this. So instead of traveling in a straight line, which light does not do, light always travels in a wave like this, and that creates some very important properties of light, which we'll also talk about later. When you talk about different types of light, they all would have a different picture that you could draw with respect to how tight or how far apart the waves are from each other. The distance between the peaks of two waves is called the wavelength, and it has the symbol of lambda. There it is right there. So lambda is the length between two tops of the wave. How big the wave is away from the central line is the amplitude. So for example, if you were talking about sound waves, the higher the amplitude is, the louder the music would be. And so that's just the amplitude that way. The wavelength is much more important. The ones that go up are called crests, and the ones that go down are called troughs. Now, frequency is very important. As these waves get more tightly pushed together or more firmly pulled apart, as you'll see in the book and already has, that's called the frequency. The frequency has this little funky V shape as its symbol, and it comes in a number of them per second. So if you had 10 events per second, the frequency would be 10 per second. If you had 1,000 per second, it'd be 1,000 per second. And these are also called hertz. So hertz is equal to per second, and common light, like you have coming from this light here in my house, for example, is probably got a frequency of somewhere around 180, 200, and that means that it's turning on and off very, very rapidly. And we'll talk about lights in a little while here. There is a very, very important equation that goes along with this idea of waves and particles traveling as waves that says that the frequency of any light is equal to the speed of light, which is 3 times 10 to the 8th meter per second, divided by the wavelength, which always comes in meters, because it is, in fact, a length. So be sure to write down this equation. You'd want to memorize it because I will not give it to you on the test. I will give you the value for the speed of light, so you don't need to memorize that. So be sure to memorize this equation, look at this picture long enough that you understand where wavelengths comes, etc. Now, light is very, very cool. There are many, many different types of light. So if you talk about light, you can start with high energy and you can go to low energy. So let's go this way, and we'll go low energy here and high energy over here. And there's a whole bunch of different types of light. The lowest energy type of light are radio waves, and this is how radio transmissions are sent out. Then you have radar, microwaves, which shake things, and that's how we warm up food. Then right after microwaves comes the infrared, and then that comes this very important sliver of wavelengths of light called the visible wavelengths of light. And these are very important to human beings because this is what we see.